You know, it's always a strange thing when we have numerous storm cells around the U.S., but very little in the way of severe weather. There's a look at Alabama. You can see a few outflow boundaries kind of racing through. And then the last frame shows the Carolinas. Numerous cells out there, and you can see a very strong south to north flow there. Many cells to look at there, but as far as severe weather goes, it's pretty scattered there. Just a couple of hail reports there in the Texas Panhandle, and one little report up there north of Topeka. That's about it for the plains, and yeah, there's that one in the Black Hills of South Dakota. I figure it's time to take a look at the 500 millibar hemispheric chart. This is up at about 18,000 feet, so this is in the mid-levels of the troposphere. And this gives us a kind of a look at the game plan as far as the steering currents, where the cold and warm air masses are, and of course the important ridging and troughing. Now, what we have at this time, we've got pretty much a long wave ridge across the west coast there. And of course that's very bad for storm chasing. What we want is we want a trough to the west and a ridge out to the east. And that gives us a flow that's kind of like that right there. So we end up with southwesterly flow, and that also brings stronger zonal component across Colorado and New Mexico, and helps gets the storms more organized, and really gets activity going along that dry line. So in spite of the fact that we do have a ridge out to the west, we've got this cutoff low in California there, and accompanying that low there, a jet stream running from about Los Angeles up to Colorado and Utah. So let's roll this forward. We'll take a quick preview what's going to be happening over the next couple weeks. Now we can see that very pervasive Rex blocking that we were talking about a few days ago. A Rex block is when we have a trough south of a upper level high. Now technically this should be a closed low and a closed high. And of course that creates kind of a traffic jam out there in the Pacific. So while the Rex block that we had a few days ago, while that kind of did break up, you can see the pattern trying to reestablish that Rex block going into Thursday and Friday. So there's that high pressure area building in British Columbia. However, there is a bit of a wild card coming in from the west, and that's a strong trough. And there's one trough right there, and here comes a strong one that's even further south. And you can see what this does. It digs in there into California around Tuesday, and that picks up the flow again out in the Four Corners area in New Mexico and Texas. So that should keep the thunderstorm chances going for at least another week there. So in spite of the fact that the prevailing flow has a big ridge out to the west, we're getting these small troughs appearing, and that's helping to save our bacon there. So where did this trough come from? Let's backtrack that. And there it is. So at this time, that little disturbance is between the Aleutians and Japan, just off of the Kurile Islands right there. So that's what we're looking at right there, and that's going to be affecting our weather next week. So there it is digging in, and that'll help break down that bit of ridging that we got. Now another way to look at the flow is to look at the Hofmuller diagrams, and I've got one here. And this is a plot of longitude versus time. Let me see if I can fit that on the screen here. You can see down at the bottom there's speed in meters per second there. So basically the darker red color we have, the stronger the flow. And this is actually a plot of meridional flow. In other words, how strong the north-south component is. And another chart we can look at is the zonal wind. Let me bring that one up. So what I'm looking for is fast flow coming out into the plains. And what we have to watch for is this band right in here. 120 is going to be about California. 90 is going to be pretty close to the Mississippi River Valley, so the Great Plains is going to fall right in here. And you can see that we're under this weaker flow. Let me get my bearings here. Oh, we've got a little bit of strong flow actually right there. That's that bit of jet energy coming in from the Four Corners. However, we can see the next system appearing right here. And what's important is we're seeing it progressing. If the systems are stationary, they tend to have kind of a vertical orientation there. So thankfully we're seeing kind of a bit of slope there. And we can kind of use this diagram to find when the next system is coming in from the west. So it appears towards the 27th or 28th. There's a finger right there coming into the Great Plains. So as far as the weather, let's check that out. No watches. We've only had an enhanced convective outlook area, and I think that's actually all the way down to marginal. Okay, yeah, we're looking at just marginal areas there along the caprock, and I think these are just going to be general areas out over the southeast U.S. Okay, let's go ahead and check out the surface chart. And I've got the data loaded here. So all we need to do is get everything plotted. And I'm using digital atmosphere here for these maps. Okay, so here comes our data, the isobars, the fronts, and the mixing ratio, which is essentially our dew point. So our stationary front has made it even further south, all the way down to Dallas and Abilene and almost all the way to Midland there. A very weak push of cold air bringing that southward. So possibly some of the storms that we're seeing out to the west are forming along that boundary. Others, of course, over the higher terrain around Marathon, Texas. Okay, let's check out the mesoscale chart. This will give us a closer look at our boundaries. We can see very light flow. However, it's got an easterly component. So we're kind of under the influence of some of that high pressure out to the east. I think we're seeing that help shift the wind around a little bit. So even down in the South Texas area, the flow is kind of weak there, but they are out of the south. And I think we can probably piece together exactly where that boundary is. It looks like it's running something like this right here. So our front is gradually sinking south right there. And you probably noticed on the opening clip that the dew points had fallen. Yesterday they were 68, and now we're down to 58 to 59. And that's another great sign of dry air infiltrating the area. Down to the south of the boundary, you can see how the dew points are much higher. Lots of mid and upper 60s there. So moisture, definitely a distinguishing characteristic there of air mass source. Okay, we do have a few outflow boundaries out there in West Texas. You can see the gusty winds out in that region. So we probably got a few boundaries kind of like that right there, and you can see the very strong difference in moisture between Midland and Big Spring. So out here, this is going to be post-dry line air, and the dry line itself, that appears to be roughly like that, and it's been disrupted by the outflow, but it's continuing north around Amarillo, up in that area there. Okay, anything else to look at? I'm trying to think if there's things we can show you here. Maybe I can run through maybe one of these mesoscale analysis panels. We're looking at the SPC mesoanalysis site. That's at spc.noaa.gov/EXPER. And if you go to that, you just click on the mesoscale analysis. And we've got all kinds of different products we can look at, and all of this is based off the rapid refresh model. Now, thermodynamic parameters, this is one thing we can look at maybe for tonight. One thing that's very helpful, they've got these help boxes, and that'll help give you a little bit of background what each one is for. So CAPE, this is going to be surface-based. So this is not taken into account the moisture structure just off the surface. So this is using strictly the surface dew point. So we'll take a look and see what the numbers are like. They're not terribly high there, just peaking at about 1,000. That's kind of a threshold value for thunderstorms. I think I can see a few 2,000 and 3,000 values down there. And then we get a little bit of shading. And it's helpful to look down at the bottom and be sure to read these legends. So we're seeing the CAPE, which is the contour, and the convective inhibition, which is going to be the shading. So that can help give you some idea of where the strongest capping is located there. So down to the south, this is where we pick up the higher values. We also have, of course, the mixed layer method. This considers only about 1,000 millibars deep, which is going to be about 3,000 feet. Looks like we smooth out some of the noise there. And the values that we see with mixed layer CAPE computations are naturally going to be a little more lower because of the influence of moisture just off, or of dry air just off the surface there. So the values, you can see we've got a little bit of a, I'm trying to figure out which one is a ridge and which one is a trough. Yeah, this looks like a CAPE ridge right there. And here we have depressed values of CAPE. Now typically what we see is a more concentric appearance when we have a major storm day. And I'm trying to think, I might be able to bring up the El Reno day. I may be able to bring up this chart or some chart kind of like that. Let me see if I can get that going here. Give me just a second. I have to tie into my archive directory. Okay, that was going to be 2013. That was on May 31st. So yeah, these are the different, this is the archive data I have for May 31st, 2013. I warehouse a lot of this data here because you never know when you might need it. Now it appears I don't have any upper air data, but I can certainly pull down some surface vorticity plots. So let me bring that up. I'm going to pull up a chart for about 20, just before convection, about 21Z. Okay, so we can go ahead and look at that. Let's see here. Okay, So I got the plots here. So we're going to look at El Reno, the big tornado, central Oklahoma 2013, Southern Plains, and this is how the field looked. And this gives you some idea of what these charts are going to look like on a major storm day. So what are we looking at here? You can just refer down to the bottom. Surface vorticity, that's going to be the fill colors. So the green and yellows, the shaded areas. And then divergence and convergence, those are going to be the contours. So taking a look up to the north there. This vorticity field is not the same as upper level vorticity. Structurally it is the same, but we use it differently. You can't look at the wind and find out where PVA is. That doesn't really help you down at the surface. Where this comes into play is it helps us find boundaries, and we can definitely see that linear structure right there indicating the location of a boundary, and another one down along the caprock there. And it looks like possibly a triple point there around Altus, but this storm formed around Weatherford out in this area here. So that was along this very weak front coming in from the north. And how does it look today? I'll pull up the very same diagram. So that particular chart is going to be over here. Surface, divergence vorticity, and then we changed the sector to bring up the southern plains. So we can kind of compare El Reno to today. So not really any comparison, but it's a very noisy field due to all the weak boundaries and the weak flow and so on. But out to the west, it does appear that maybe we're picking up a little bit of the dry line structure out there in West Texas. So if you're doing a lot of hand analysis, definitely use these charts to help refine and give you perspective on what you've just analyzed. And of course we often use this velocity tensor magnitude. It'll give some patterns that look a lot like vorticity there. You can see that this kind of resembles maybe where the dry line is located. And this is where we have stretching and that kind of thing working on the different parcels out in that area. So let's go ahead and keep things rolling along since we're about 20 minutes in already. We haven't even gotten to the satellite. 250 millibar chart showing that strong jet entering the southwestern U.S. there. And down further south we can see the subtropical jet. So I think this here is probably a polar front jet, and this here is a subtropical jet. So different root causes on those. 700 millibars checking in on the temperature just for a rough idea what the cap temperatures are. Still looks like the caps are on the weak to moderate side. Definitely weaker up in Nebraska and Iowa, but they don't have the moisture up there to get storms going. And it appears the temperatures are holding pretty strong there at Midland. And then 850 millibars, that's going to be at 5,000 feet there. Looks like we're still hurting as far as moisture goes. Only 30s dew points at 5,000 feet at Fort Worth and Oklahoma City. But we're starting to pick up this 40-knot jet at Midland this morning. This chart is for this morning. And dew points running about 57 to 61 degrees there. So the moisture supply pretty much coming right up to caprock, and that's a big reason why we're seeing a lot of the storms far out to the west there. And then finally, of course, that brings us to the thickness and isobars. Up to the north, it's like a front up there in Quebec. It looks like kind of a backdoor front there in the Dakotas. And then down to the south, we can't really use this chart to pick out any boundaries. I do see a little bit of troughing in this region right there, so I might be inclined to put a front somewhere in here. We really need to use that analyzed surface chart to really find where that is. Out in California, it looks like some changes out in that region. There's 4 thickness lines, so we probably have some cold air moving through California, helping to support maybe a weak front in that area. And that is supported there, 250 millibars. Trough out in that region right there, the upstream ridge probably about right there, and that would put the baroclinic low. Southern Nevada there, and the frontal system's like that, and that's just kind of the rough guess, and that corresponds very closely with that thickness analysis. So kind of a weak frontal system starting its move into Arizona, and it should be emerging out into the plains maybe around the weekend. All right, it's about time to check in on chat. Let's get our satellite loops going. There's the visible image there for the Great Plains. Looks like a kind of a quiet night in chat. This is, of course, the middle of the week, and there's not a whole lot going on. David Lumbert, Arkansas, has a mesoscale convective vortex system moving through there. Temperature 73. Electric Dog also 73 in Illinois. Ron Chalfant reporting a nice day in Southern California. Erica Baker, Coffeyville, Kansas, 81. Got Burl H here in Fun with Tech, reporting a flash flood warning in his area there. Sue M in Indiana. Alexei Pinkson Walsh out there in Texas. Hot day there. Michelle Curlin providing some information on the flowers there. I appreciate that. Megan John, 84 in Minnesota. Dean Benedict here in northwest Pennsylvania. Let me switch the satellite here. Robert Pleasant, 70 degrees in, I think, Tennessee. GFS and Euro on board now with possible tropical system. Oh, the GFS is picking up on that. That's interesting. I was starting to wonder there whether that was spurious convective blow up there in the Gulf, and I think Jeff Krob was mentioning something to that effect there. So we'll take a look at that. Clyde Hoadley, Arvada, Colorado, 78. Mike R, San Francisco, reporting a couple of showers today. And I appreciate the comments, Dean Benedict. Mike R says Rex Block caused the delay in the rainy season. Willie Greenway joining from Georgia. Ryan Toomey's in Florida there. Looks like he's reporting some wind there. Continuous rain. Flight delays out of Fort Lauderdale, Miami, and Palm Beach. Still dealing with the low spinning out in the Gulf, dragging all the Gulf moisture over the state, 68 inches. Mike Estwick, Denver, 80 degrees. And Carl Berghoff joining us, Shirley Keast. Very warm day in Michigan. Good deal on that fishing. That sounds really nice there. And yeah, that's pretty much most of the chat there, and we can see that stormy weather there in Florida. A lot of shower activity across the southeast this evening. Let's take a look at a couple of soundings. I know people like that practice with a sounding. We're going to pick out a couple of different regions. We're going to start with Texas. So kind of a sunny day in Texas, some moisture, but not much going on. We're going to look at Yuma. very hot in that region. Also, we'll look at the southeast U.S. at Atlanta with that showery pattern. We'll try to go up to Michigan. I'm not sure what site. I think there's one up here around the northwest part of the lower Michigan. And we'll also try to look at Washington. Looks like they're back in behind that cool system there. I'm trying to think back on the chart what we were seeing, but we'll just look at the SQT and see what's going on. So let's start our tour, beginning with Fort Worth. Okay, there's the Fort Worth sounding taken about an hour ago. Very light winds down in the lower levels, but it looks like the flow is picking up a little bit there in the mid-levels. So if we had a little bit more moisture and instability, that would probably start to support some organized storms there. The moisture definitely there. It's not too strong. You can see we're starting with a dew point around 15 Celsius. That's right around 60, and then 50s all the way up to 5,000 feet. So if we do just kind of a quick test lift using a temperature of, say, 89, I'm going to select the 10.2 mixing ratio line. We should really do a SQT program. Maybe I can see if we can do that this weekend. Anyway, the lifted parcel is going to run something like that. We've definitely got CAPE. However, we've also got convective inhibition. That's probably about 200 for the convective inhibition right there. So that's helping to suppress the storms. That 9 to 10 Celsius temperature is helping to keep things capped. If we had a little more moisture, say we had a 65 degree dew point with an increase in moisture up to 5,000 feet, let's say that would change the diagram to this for the moisture. And then doing our lift, there's our mixing ratio right there. We lift from 88 to 89 again. And the cap's still a problem, but it is definitely a lot weaker there. So the CAPE increases, and the convective inhibition is lower. So that could be what's going on out west. Maybe a little bit more moisture out in that area. But one of the other factors that's helping to reduce the moisture is the north flow. It's advecting in drier air from the northeast. Northeasterly direction, I should say. Important to clarify that. Okay, the next station, that's going to be Yuma. Way out in the desert, heating up. Don't have a sounding for this evening, but we'll see if we can back that up and look at earlier today. Oh, we get an animated sounding. That's interesting. And they've had multiple launches. How about that? Okay, so this is the latest sounding we have, and you can see the very steep lapse right there. That's the heating, the strong heating. And we've also got very dry air, dew points in the 20s right off the surface. So if we were to try to do a convective parcel lift, it's going to look, let's see, we'll use about 98 degrees. So our LCL is going to be up at about 16,000 feet. And there's the lift along the moist adiabat. So this is all the capping, and there's no positive area at all, so no chance of thunderstorms in that area. But if we add a little moisture, monsoon weather often brings 50s dew points. Let's change this. So we'll say the moisture changes to that. And you can see we're a lot closer to a convective situation. Very little convective inhibition and starting to get some positive CAPE there. So that's all it really takes there is an increase in moisture. Atlanta, they're getting the storms today. Okay, we've got the latest sounding. And this is a classic tropical sounding. The column is almost moist adiabatic. It's kind of leaning over a little bit to the left of the moist adiabats. That's these lines right here. And definitely tons of moisture. So a lift is going to look something like this. Very weak capping, so we're seeing numerous storms in that area. And then we've got this long skinny cape helping to produce mostly showers and thunderstorms with that amount of instability. Northern Michigan, let's click on that one. So I guess they've kind of warmed up. There's the evening sounding in that area. It's dry there, 30s dew points. However, you can see the lower part of the temperature trace. It's almost dry adiabatic, indicating either strong solar heating or modification of the air mass, or maybe a little bit of both. Then the next sounding is going to be the northeast U.S. I guess we'll pick Quileute. And you can see a very strong inversion right there. So that's probably a frontal inversion. So that's topped out at about 4,000 or 5,000 feet. Above that, lots of warm air. A little bit of elevated moisture there, so that's favorable there for showers. All you need is a little bit more moisture, say around this level right here, and that'll give you enough elevated CAPE to get some shallow, high base storm showers going in that region. And let's see, we'll throw out one more wild card. Let's try Greenland. That station right there. Let's see what's going on out there. It's certainly warming up. Okay, that's the evening sounding for Greenland. Down there in the south part, you can see the tropopause very low. You've got kind of a surprisingly strong bit of slope on that line right there. So even in Greenland, that's probably a consequence of maybe some increased heating and modification of a cold air mass. Got strong winds right there. And the column is showing a very high relative humidity, so likely a lot of altocumulus, altostratus, and cirrus with this particular sounding. All right, so it's time to head into the forecast, and I'm hoping to bring back the journal tutorial, but that was kind of a little bit too much for me to handle. I think maybe if things slow down just a little bit, maybe I can pick that back up in the next few days here. So we'll start with a rapid refresh. There's our spotty showers across the Central Plains. And all of that activity dies off overnight. A little bit hanging on there in Arkansas, so we've probably got a little bit of dynamic lift, or maybe a little bit of strong upper level flow helping to keep those things going. High pressure, there it is right there, 1014 millibar high, and we've got a flow of wind coming southwest from that high. That's helping to keep things kind of dry in Kansas and Oklahoma. Okay, we'll take a look at the upper air. There's the NAM right there. We can see the stronger flow coming in from the Pacific. So going into tomorrow, we're going to have a ridge creeping out over the high plains right there. So we've got the lift concentrating just to the east of that ridge. So we'll probably see some very warm temperatures on the soundings, Dodge City, North Platte, out in that area. And then as the day goes on, that ridge begins moving off to the east. And we start bringing the high plains under stronger upper level flow. And you can see the cyclonic flow starting to approach there. And also there's the strong upper level winds from Arizona into western New Mexico there. And then by evening, it's looking like this here. There are some spots right here on the high plains. That's where the storms appear to be going up. Looks also like maybe some activity up there in North Dakota. Then going into Friday, that ridge kind of splits up. One part heads into North Texas, another into Nebraska and Wyoming. And then this trough starts approaching into New Mexico and Colorado. So by evening, we're looking like this. It looks like a pretty potent jet max coming out into West Texas. So I would expect to see some strong storms for Friday. Maybe some good chase prospects out there around Lubbock. Also a pretty good trough out there in the Midwest. That should get some storms going out in that region too. Then for Saturday, looks like that energy moves out into the Central Plains. There's our jet max moving up towards Iowa, Nebraska, maybe chance of storms there for Kansas City and Omaha out in that region. A little bit of troughing working into the panhandles. And then by evening, we're looking like this. It looks like another shot of lift coming in from the west there. Try that one more time. Yeah, there's that jet max coming in from the Big Bend area on Saturday. And I figure I'll throw this into supercell composite. And let me bring up the definition of what supercell composite parameter is. Okay. Okay, this is our these are our definitions here. And you can see we've got the supercell composite parameter right there. And, of course, the related significant tornado parameter. So it's very easy to get them confused. And the only way to really get this firm in your mind is to use them, refer to them often. Supercell composite, of course, is the most basic one. And this basically evaluates your risk of rotating storms. And the terms that go into it are CAPE, most unstable CAPE. This is basically a measure of your instability. Then we have your effective layer, storm meltophilicity. So that's a measure of your low-level shear. And then the bulk wind difference in that effective layer there. Then really about the only difference between that and the significant tornado parameter is the addition of LCL, which is kind of a function of relative humidity and convective inhibition. So usually your most accurate parameters are going to be the simplest ones. That's just kind of a basic rule of thumb because there's less probability. It's basically the more terms you mix into an index, the more chance you have of something going wrong because that increases the complexity of the index, and that's not always desirable there. So we're using this SCP, and let's see how things change from day to day. This is how it looked this evening here. Very modest SCP. So that's kind of a threshold value down there in West Texas. Then for tomorrow, looks like we got two areas, one around Amarillo, up to southeastern Colorado, and another up in North Dakota there. Then for Friday, looks like things kind of firming up there in southwestern Kansas, maybe out towards Stillwater. And it appears that the dry line is showing up. Now, I think this was the day that the jet max was starting to pull out. Maybe that was Saturday when that was happening. It seemed like towards the end of that NAM run, we were seeing some strong flow coming out into West Texas there. Let's see how it looks on Saturday. Well, the SCP is still low in that area, so we're definitely missing out on a parameter. Let me sample in this moist air mass what it looks like around the Snyder and Post area on Saturday, and we'll find out what went wrong there. Well, the Cape is definitely up. This is the significant tornado parameter. Remember, this is related, but it adds in a few more parameters, but we can still use this to judge the contributions to SCP. So we just look at the Cape, helicity, and bulk wind difference. So really, things are kind of depressed except for that Cape. And then looking at the sounding data itself, yeah, very gradual, weak shear. It's really stretched out vertically. Definitely got the instability there, the very strong lapse rate there. And it appears that the helicity is a little bit weak too. We do have directional turning of the wind, but that's way up at about 8,000 to 9,000 feet. So that kind of answers what the problem that we're having there. But this SCP product, this is very useful for picking out where to do that forecast sounding. You can see how on each day the moist area shows up, the moist sector. See, like right here, we can see the outflow from these storms, and you definitely don't want to sample in the storms themselves. And then on Friday, yeah, see, there's some outflow right there. Then on Friday, when that dry line shapes up, we can pick out exactly where that is. So when you're setting up your forecast sounding, this will help you make sure you're sampling a correct area that's not in outflow, that's not west of the dry line, and so on. So basically anywhere out here is fair game. So right there you can pick out what's happening on Saturday there around Snyder. So yeah, we are getting some pretty good moisture there. I wouldn't totally write off Texas for Saturday, because May is always full of surprises. And wow, look at that helicity up there on the photograph. That's really fantastic helicity. You don't need a whole lot of instability to get tornadoes out of something like that. The algorithm not forecasting anything, and let's see what's cutting it off. Yeah, Cape is very good. I think the problem is it's picking up on this strong convective inhibition. Yeah, that shear looks really good there. So let's go ahead and head into the long term, looking at the GFS. Start out around Saturday here. Looks like we got another front coming in from the north. Probably got a chance of some warm front activity right there for Saturday around Kansas City. Then going into Sunday, that front is going to continue to sink southward. Looks like it's stalled out maybe in Oklahoma there. And it doesn't appear that we're seeing much happening on the Great Plains. You have to go pretty far out west in that region. So what's wrong? Forecast sounding for Sunday for Oklahoma. We've got good moisture there. I think we definitely got Cape there, and the Cape factor indicates the instabilities there. Yeah, the weak bulk shear there. You can see that the 5-kilometer wind's only out of the west-southwest at about 30 knots. However, if we have a boundary, we can definitely get storms going. Then for Monday, here's how things look. I think we probably got that warm front moving back north. So it looks like storm activity possible for Kansas. Then for Tuesday, that warm front is probably up in Nebraska now. Some more chances for storms up in that area. Not too sure about the Great Plains. That's going to depend where the dry line is. Then for Wednesday, looks like our warm front is stationary up there in Nebraska. Probably some potential in that region. Then for Thursday next week, 24th, I don't see any clear targets here. I think we may be underneath a ridge. And we can take a look at the upper flow to know that for sure. Yeah, very weak flow aloft, 15 to 25 knots. So I guess we're just kind of ridged out there towards the end of next week. But down to the south, GFS trying to bring a tropical storm in. And let's see where it takes it this time. South Florida, Louisiana, and then into Texas. So I don't know, we can probably take a quick look at the European model and see if it is picking up on that. So let me bring that up. Okay, yeah, this site here is the Euro weather. You can see here eurowx.com. And I've got an incorrect password. Let me try that one more time. Okay, I think we're good to go here. So, yeah, this is a great site for European model data, eurowx.com. So we've got permission to use these charts here, and I definitely appreciate that. So let's bring up the basic sea level pressure. Now, one problem, I think, is that this is not going to go out quite far enough. We only go out to 240 hours with the European model here. Or at least that's all we have access to. So we'll check it out anyway and see if anything's going on down there in the Gulf. All right. Gradually bringing in our frames. It's like waiting for Windows to install. Okay. All right, do we have a readout of the date? That's going to be at the top, so I'm going to probably have to do this. So yeah, up here you're going to see the valid date and time. So there's 72 hours. Just take a quick look at the plains. Looks like some storms there for Saturday night around the Lubbock area. Yeah, so we'll probably have some potential there along the dry line for Saturday. Also for up around Kansas City, possibly some potential there. Then for Sunday, there's the Sunday evening forecast, and we can see that front pushing into southern Oklahoma all the way down to West Texas. So not much being picked up on the low plains, but out around Midland and Fort Stockton looks like some good storm activity in that area. Prospects for Monday, European model breaking out something right there around Abilene. Then for Tuesday, I don't see any focus here for any severe weather, but it's laying down a whole lot of precip. I think maybe our precipitable water has been coming up quite a bit early next week there, so I think we're getting somewhat of a tropical pattern setting in the middle of next week there. Then for Thursday, looks like that kind of everything pretty much shifts north there. Colorado low is coming together, so maybe some upslope storms starting to develop there. Kansas-Nebraska border. For Thursday, that low organizes a little bit more, so I think the dry line is going to be active, possibly some east-west boundaries, and I'm not sure if that's going to be an MCS or discrete convection, but in any case, looks like storms for Thursday also. And then there's Friday's forecast. I don't see any definite focus here for storms, but it looks like down to the south, yeah, the European model has got something in that same area there. And then the last frame, there it is, showing up. So I guess maybe we do have maybe an indicator there of possible tropical cyclone development, and it's not unprecedented. May does tend to be a very common time for very weak hurricanes and tropical storms. So, like I said, we'll just kind of keep an eye on it there. Ryan Toomey's weighing in on that, mentioning the GFS model, 150 miles either direction. And yeah, we're seeing big changes from run to run. So there's no accurate track on this or even a date for landfall. Florida drought over. Yeah, that's great news. Glad to hear that. And just a quick run through the chat. Funwood Tech giving us a link to the Jetstream website. I appreciate that. David Lumbert likes the idea of that SCUT class. So yeah, I'll keep that in mind there. Squiggly lines to the left. Yeah, Carl Berghoff, I appreciate the help there in chat. Yeah, and I think I'm pretty much all caught up there, so we'll just run our music. All right, great. Let's join back tomorrow, and we'll take a look at the storm action. Probably going to have another active day out in West Texas, maybe up into the high plains, and we'll cover that in detail. And I'll try to get working on those journals. So in any case, hope you all have a good evening. Take care, and we'll see you tomorrow. Bye-bye.